Ever wondered why explosions in outer space never make a sound? Even though what's exploding are giant stars, asteroids, or even two black holes. This story will take you deep into the quietest mystery in the universe, one that's way cooler than any boom you've ever heard. Imagine you're riding a spaceship and see an asteroid explode far away. The flash of light is insane, but strangely, there's absolutely no sound. Total silence, like watching a movie with the speakers unplugged. You might think, how could something that big make no sound? Well, that's the unique thing about outer space. There's no air, wind, or gas dense enough to act as a pathway for sound to travel to your ears. Sound needs a medium to move. On Earth, it travels through air. Underwater, it travels through water. Even walls can vibrate and carry sound. But in a vacuum, there's nothing there to vibrate. So when a huge explosion happens, whether it's a dying star or colliding asteroids, you only see the visuals: light, cosmic dust, and flying debris. But sound, it can't reach you because there's no route for it. Imagine yelling in a vacuum. Your mouth opens wide, your throat vibrates. But what comes out? Nothing. Even if your friend stands 1 meter away, they still won't hear a thing. That's why astronauts communicate using radios. Their voices are converted into electromagnetic signals, which can travel without air. Once the signal reaches a friend's helmet, it's turned back into sound. Back to that explosion. In sci-fi movies, you always hear a massive boom in space. But in reality, if you were there, you'd only see bright flashes and dramatic visuals. Space explosions are actually scarier than anything you could hear. You only see how powerful they are, without knowing how terrifying the energy would be if it occurred close to you. Take a supernova, a giant star's explosion. If it made sound, the volume could deafen entire planets. But because the vacuum blocks sound, all you see is light bright enough to outshine a whole galaxy. Even in silence, the explosion still carries unimaginable power. Supernova dust can form new planets, and the elements that formed life on Earth may have come from such explosions. So when you witness a space explosion, you're actually watching a major process that shapes the universe. Silence doesn't mean weakness. In that silence, the strongest forces are at work. Imagine floating outside a space station, and a tiny piece of debris hits a metal panel. You won't hear a ting, but you'll feel the vibration through your gloves or suit. Because vibrations can pass through solids, but not through a vacuum. Sound is basically a vibration that fails to find a medium to travel through to your ears. Still wondering why it's so quiet? Remember, in space, particles are extremely far apart, too far to carry vibrations. Sound needs a bridge, and out there, the bridge is broken. That's why astronauts often say, space is beautiful, but incredibly silent. The silence isn't like a forest at night or an empty house. It's absolute. No frequency, no echo. Light can travel because it doesn't need a medium, it just needs space. But sound, it's picky. It needs something to ride on. Without a medium, it simply disappears. If you watched a star explode through your spaceship window, you'd just say, "Wow, amazing," without covering your ears. No matter how loud the blast should be, the sound can't reach you. But don't be mistaken. The explosion can still be dangerous. Its radiation, heat, and energy waves can wipe out anything in their path. It all just happens in total silence. Space's silence makes every phenomenon feel more dramatic. You can witness something terrifyingly powerful without any sound behind it. Only light and motion tell the story. And behind all that, one mystery remains. If sound can't be heard, could a space explosion still create a sound you can feel in another way? That question gets you thinking. If sound can't travel through a vacuum, is there another way to hear a cosmic explosion? Turns out the answer is yes, and it's way cooler than ordinary sound. In space, scientists don't use ears to listen to explosions. They use instruments that detect energy waves, light, and gravitational ripples produced by extreme events in the universe. One of them is gravitational waves, tiny ripples in space-time caused when two supermassive objects collide. It's like sound, but in the form of small distortions passing through the entire universe. When two black holes merge, there's no boom. But detectors on Earth can record those gravitational ripples. It's like feeling the vibration of bass from a speaker, even without hearing the music. And funny enough, those gravitational ripples can be converted into sound. Scientists turn the data into audio, and it comes out like a rising chirp. That's the interpreted sound of a cosmic collision. So even though space is silent, humans can make it speak through data. You don't hear the explosion directly, you hear its translation. Pretty awesome, right? But that's not all. Cosmic explosions also emit waves of light, X-rays, gamma rays, and visible light. All of this can be detected and decoded like a secret message. A star explodes, debris flies, radiation spreads. Each of these sends signals across space. Not audio signals, but energy signals captured by modern telescopes on Earth and in orbit. Sometimes these signals are so strong they trigger automatic alerts in observatories. Scientists get excited. It's a supernova. It's a neutron-star merger. All from silent vibrations. Imagine watching a supernova flash from your spaceship window. You hear nothing, but your ship's instruments instantly detect a spike of radiation and energy waves. Those instruments send the data to a computer, which translates it into graphs, colors, or even synthetic sound. You end up hearing a cosmic explosion through technology, not through air. In fact, most space sounds that go viral online aren't real audio, they're data sonifications. Radiation turned into notes, light turned into rhythm, gravity turned into frequency. So space is silent, but not storyless. The energy from every explosion carries information we can read with the right tools. The universe is talkative. It just uses a different language. There's one unique exception. If you're near an object with a thin atmosphere, like Titan or Venus, you can hear faint sounds. That means explosions on other planets can make noise if air is present. But in the vacuum of space, where stars explode, planets collide, and black holes swallow light, silence is the law. You can only see, feel vibrations, and read the signals. When a black hole devours a star, you won't hear a scream of energy. But the emitted X-rays can be detected by special telescopes. It's like hearing a silent scream. As you understand more about how the universe communicates, you realize the universe's most powerful explosions happen without a single sound. And that silence makes them majestic and mysterious. Silence isn't a flaw, it's part of space's identity. Behind that quietness is immense energy spreading outward, carrying stories from billions of years of galactic history. You finally understand, sound is only one way to understand the world. In space, what speaks is light, gravity, radiation, and energy waves. The universe is full of sound, we just lack the ears to hear it. And when you witness a silent cosmic explosion, you realize you're seeing one of the universe's greatest performances. Silent, yet more expressive than any sound could ever be. And if you like stories like this, or are interested in similar topics, don't forget to subscribe to this channel. By subscribing, you won't miss out on other exciting content. In the next video, there will be an even more interesting topic. It could be more mysterious, more entertaining, or even more surprising than you imagined. Don't forget to turn on the notification bell to stay updated. Likes and comments also help this channel grow. Thanks for watching, and see you in the next video.